So, student, last time we have studied about the differential equation of SHM. From differential equation, we have derived acceleration, velocity, displacement. Again, in that displacement, we have seen that when particle will start from mean position, then what will be its displacement? When particle will start from extreme position, then what will be its displacement? Then also one more important point we have seen, that is when the particle velocity is maximum, when body is performing SHM, when acceleration is maximum or minimum, when particle is performing SHM. So all that thing, the basic things we have studied. Now today what we are going to consider, that is I have shown you SHM when particle is moving to and fro along a horizontal line. Right? And now, instead of as a one particle, now if I am saying that there are two particles are present. Now, two particles means what? We can consider, we are going to take two springs. So, I can say that the two springs are connected in series. So, now two springs are connected in series, that I can show in two different manners. What is the first thing? First, I will show this first spring S1. Second spring I can show here as a S2. This S1 and S2, they are connected in the vertical plane in series, and at the end of S2, I can attach a certain mass. And to that mass, if I pull that mass, means I am going to apply a certain force. So when I am going to apply a certain force, so this spring S1 as well as this spring S2 will get extended. Let's consider P1 is the extension in spring S1, P2 is the extension in spring S2. This is one way by which we can connect in the series combination. Second way, how we can connect in series in the horizontal plane. Let's consider this is S1, here is your second spring S2. At the end of S2, I can attach a certain mass, and to that I can apply a certain force. Means what? Again I say in S1 I am getting extension P1, in S2 I am getting extension P. Clear? Any doubt here? Okay. Now when I am going to apply force F on S1, same force will be applied to S2. Is it right? Means due to this force F1, in spring S1, there is the extension E1. So that I can say that, suppose in spring S1, I can say that in spring S1, force applied is F1, corresponding extension is E1. So that equation I write down, F1 is equal to K1 into E1. K1 is nothing but the spring constant of the first spring. Similarly, in spring 2, I can say that force applied is F2, corresponding extension is E2. Therefore, I can write down F2 is equal to K2 into. Clear? But these F1 and F2 are not the different forces. F1 and F2 are nothing but the F. Because same force I am going to apply for both the springs. Means what I can say that F1 is equal to F2 is equal to somewhat F. Means now this equation, how I am going to write down this? Your F K1 E1, F K2 E2. Therefore, I can write down extension E1 is equal to F upon K1. Extension E2 is equal to F upon K2. And now, due to application of this force, I am getting a total extension. So what I can say that total extension E in the spring, total extension in both the spring, E is equal to E1 plus E2. But this total extension E is due to which force? F. Means this value of E Here I can say that value of E is nothing but F into resultant force constant by the same formula. Here how I have written E1 is equal to F upon K1, extension in the first phase. E2 is equal to F upon K2, that is extension in the second phase. So total extension E can be written as total force applied divided by resultant force constant. So instead of E, I can write down F upon K, which is equal to now E1 value F upon K1 plus F upon K2. From both the sides, this F factor will get cancelled. Means what I'll get is 1 upon K is equal to 1 upon K1 plus 1 upon K. So this is nothing but the resultant reciprocal of resultant force constant when the two springs are connected in series. Now here we can make number of modifications. What is another modification we can make? That is instead of only two springs, if there are n springs are connected in the series. So n springs are connected in series means what? This will get extended here and getting up till kn. Is it right? One more modification I can make it here. That is, if spring constant K value of each spring is equivalent, they are same. Means now what I can say that if the all spring constants are same, so what I'll say that here in equivalent series, so I can say here Ks. So here what I say Ks is equal to 1 upon K plus 1 upon K up till n upon K. If all spring constant K1 is equal to K2 up till Kn must be equal to K. Then I'll write down 1 upon Ks is equal to n upon K. Means simply Ks is nothing but your K upon n. Is it right? Okay. See here. Again I'll repeat. Initially what I have considered, only two springs are in series. So when two springs are in series, I am getting 1 upon Ks is equal to 1 upon K1 plus 1 upon K2. What is my second? This is my first formula for only two springs. Instead of that, what I am saying that if I am connecting number of springs, if I am saying that I am going to connect n springs in series combination. So n springs in series combination. So when these n springs are in series combination, this formula will become 1 upon Ks is equal to 1 upon K1 plus 1 upon K2 up till n upon Kn. This is the second formula. And thirdly, what I am going to say that is if all spring constants are constant, same, K1 is equal to K2 is equal to Kn, so that value I can consider as a K. So at that time your formula will become, this formula will become 1 upon Ks is equal to n upon K, means Ks is equal to K upon n. So if you are remembering, in electrostatic, we have studied the capacitors are connected in series combination. And when the capacitors are connected in series combination, we are getting 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 up till 1 upon C n upon C. So in that case also I am getting Cs is equal to C upon n. So there is an equivalence. When the springs are connected in series and capacitors are connected in series, their formulas are equivalent to. Clear? So this thing you have to remember. Now, instead of now I can say that capacitors are connected in series. Sorry. Springs are connected in series. Instead of that, if I am saying that your springs are connected in parallel. Now springs are connected in parallel means what I can say that same rigid support. From same rigid support, two springs are attached. Both the springs are attached with same mass, or I can say that if the springs are attached with different masses, so I'll say M1, here is nothing but your M2. So applied force on S1 is F1. S2 applied force is nothing but as a F2. Is it right? Instead of these two separate forces, if I am saying that I am going to apply same force here. So when same force is applied, I'll say that extension produced in S1 is E1. Extension produced in S2 is A. Is it okay? So now what I can say that here, these extension produced are E1 and applied force is F. When same F force is applied on this spring constant, this extension will remain same. E1 is equal to E2 is equal to E. But their force constants are different as a K1 and K2. So what I write down, F1 is equal to K1E. That is for the first spring, spring 1, or for spring S1. And F2 is equal to nothing but K2E for spring 2. From where this formula we have brought? From definition of linear SHM. If you are remembering, in linear SHM definition we have seen that force is directly proportional to minus x. X means what? Displacement. Means what? Extension. So instead of x, I have used the letter as it. Now here, so I can say that total force F is equal to F1 plus F2 for the two springs. So what I can say that it is equal to C factor is common. So I am getting K1 plus K2. This is nothing but F. So what I can say that F upon E is equal to nothing but K1 plus, and F upon E is nothing but spring constant of equivalent combination. Which combination is there? Parallel combination. So spring constant of parallel combination is equal to E1 plus, when this formula is there, when two springs are in parallel combination. Right? Now, instead of only two springs, now I can say that if there are n springs in parallel combination. So if there are n springs in parallel combination, I get it. Kp is equal to K1 plus K2 up till Kn. Right? But now, third thing, if all spring constants of n springs are same, so I say that K1 is equal to K2 is equal to K up till Kn. Means at that time what I can say that this Kp can be written as n into K. Again here, you have to recall your formula from electrostatic. That is, if capacitors are connected in parallel combination. So if capacitors are connected in parallel combination, so your Cp is equal to C1 plus C2 plus C3 up till Cn. And if all capacitors are of equal values, C1 is equal to C2 is equal to C up till Cn, all are equal, then they will get formula Cp is equal to Nc. Same thing I am getting here for string. Clear? So this is the equivalence. In spring in series, formula is equivalent to capacitor in series. And second thing, springs are in parallel combinations are equivalent to springs, capacitors are connected in parallel combinations. Clear? So this is about your one of the important topics. The springs are connected in series and springs are connected in. Is it okay? So there are so many numerical problems. That's it. Fine. Now the remaining thing,